Hi students, today we will start classification of elements, the periodic table. In this class mainly we will discuss about Dobereiner's law of triads. In 1661, Robert Boyle defined an element as any substance that cannot be decomposed into a further simple substance by physical or chemical change. Element is nothing but any substance that cannot be decomposed into further simple substance by physical or chemical change. That is the element. Here we can see Robert Boyle. At his time, at Robert Boyle time, only 13 elements were known. Towards the end of 18th century, by the time of Lavoisier, another 11 elements were discovered. That means by the time of Lavoisier, 13 plus 11, total 24 elements were known. By 1865, about 63 elements were known. By the time of Mendeleev, about 63 elements were known. By 1940, a total of 91 elements from natural sources and another 17 elements synthetically were obtained. That means by 1940, 91 plus 17, total 108 elements were known. At present, more than 115 elements are known. According to textbook, more than 115 elements are known. Actually, at present, 118 elements are known. If you go for a medical shop, you can see a particular order of arrangement. If you go for a fruit market, you can see a particular order of arrangement. If you go for supermarket also, there also we can see a particular order of arranging things. So from the above observations, we can conclude that for any system which contain number of things, a particular order of arrangement is necessary. A few elements were known at that days, so it was very easy to study and remember the properties of elements. But the discovery of elements increased day by day. Now it is difficult to study the properties of each and every individual elements. Therefore, it is necessary to classify the elements into groups depending upon similar properties. At present, we have 118 elements. It is difficult to study the properties of individual elements. So, it is necessary to classify them, or it is necessary to arrange them into a groups depending upon the similar properties. In 1829, the first scientist to classify the elements was a German chemist, Johann Wolfgang Dobereiner. Here we can see Johann Wolfgang Dobereiner. Dobereiner classified the elements into a group of 3. He classified the element into a group of 3. It is called triad. Tri means 3. He classified the elements into a group of 3. Each group is called triad. In each triad, all the 3 elements having similar physical and chemical properties. In each triad, all the 3 elements having similar chemical and physical properties. Calculate arithmetic mean of the atomic weight of first element and third element is almost equal to the atomic weight of the middle element or second element. Here we can see examples for Dobereiner triads. Lithium, sodium, potassium is one of the triad. If you observe lithium atomic weight 7 and potassium atomic weight 39. If you take arithmetic mean of the lithium and potassium, 7 plus 39 is equal to 46 by 2, that is 23. 23 is the atomic weight of the sodium. Similarly, calcium, strontium, barium is the one of the Dobereiner triad. Chlorine, bromine, iodine is one of the Dobereiner's triad. phosphorus, arsenic, antimony is one of the Dobereiner triad. Sulfur, selenium, tellurium is one of the Dobereiner triad. Manganese, chromium, iron is also one of the Dobereiner triad. These are the examples for Dobereiner triads. Limitations. It has some limitations. All the known elements could not be arranged in the form of triads. All the known elements we cannot arrange in the form of the triads. For very low mass or for very high mass elements, the law was not holding good. The law failed for very low mass or for very high mass elements. The attempts of Dobereiner encouraged other chemists to correlate the properties of the elements with their atomic weight. We can see multiple choice questions which are given in public examination questions. First one is Dobereiner triad in the following is. This question is given in public examination March 2017. A. Chlorine, bromine, iodine. B. Hydrogen, helium, lithium. C. Hydrogen, sodium, chlorine. D. Carbon, nitrogen, oxygen. Here correct option is A. Chlorine, bromine, iodine. Which one of the following belongs to group of atomic weight of Dobereiner triad? This question is given in public examination March 2018. Which one of the following belongs to group of atomic weights of Dobereiner triads? Here A is 40, 87.5, 120. B is 40, 87.5, 127. C is 40, 77.5, 137. And D is 40, 87.5, 137. So from this we can conclude that we have to remember Dobereiner triads, examples and their atomic weights also. So for this question option D is correct. 40, 87.5, 137. Newlands law of octaves. In 1865, after Dobereiner, John Newland, a British chemist, proposed another way of classification called the law of octaves. Octa means 8. Here we can see John Newland. He arranged all the known elements in increasing order of their atomic weight. He arranged all the known elements in ascending order of their atomic weights. He found that every 8th element has similar chemical and physical properties with the first element. He found that every 8th element has similar chemical and physical properties with the first element. This is called Newland's law of octaves. This is similar to our Indian system of music. We know our Indian system of music. Sa, re, ga, ma, pa, da, ni, sa. In the Western system of music, do, re, mi, pa, so, la, ti. Every 8th note is similar to first note, and it is the first note of the next scale. Every first note and 8th note are similar. Sa, sa. In Western system of music also, do, do. Every 8th note and first note are similar. Arranged all the known elements in the increasing order of their atomic weights. Hydrogen was not discovered at that time. All the inert gas elements, helium, neon, argon also not discovered. First one is lithium, second one beryllium, third one boron, fourth one carbon, fifth one nitrogen, sixth one oxygen, seventh one is fluorine. So first one is resemble with 8th element, that is sodium. Lithium is resemble with sodium. Beryllium is resembled with magnesium. Boron is resembled with aluminium. Carbon is resembled with silicon. Nitrogen is resembled with phosphorus. Oxygen is resembled with sulfur. Fluorine is resembled with chlorine. Is resembled with potassium. Magnesium is resembled with calcium. Here we can see Newlands periodic table. What are the drawbacks or limitations of the Newlands periodic table? This law is valid up to calcium only. This law is valid up to 20 elements only. Later discovered elements did not follow this law. Certain elements with dissimilar in their properties were fitted into same group. Certain elements, they have dissimilar properties, but they are fitted into same group in Newlands law of octaves.